Now, let us try to demystify or clearly understand the term combinations. Okay, so that is the mathematical term combinations, and often whenever students see this sign, they just leave the question. They become terribly afraid. They don't understand what this actually means. Okay, so we'll just start from the basics and using diagrams and pictures understand what we mean by NCR. Okay, so we'll be using fruits in this class, so that should make everyone very happy. But before we go on to fruits, let us choose pens. Okay, so these are three colored pens that I have here: blue, yellow, and purple. Now, if I ask you that in how many ways can you combine two out of these three pens? Okay, so I need to combine, I need to choose two pens from these three pens. Okay, so the term combinations is very simple. It is very literal in English. Whatever combination means, that's what it means in maths as well. So in how many ways can I combine two pens from these three? So you'll say first I can take yellow and blue, then I can combine the yellow with this purple, that is another way, and the third and the last way would be to combine the purple and blue together, and that is exactly the number of combinations of three pens, of two pens out of three. So out of total of three pens, if I take two pens, then the total number of combinations, even mathematically, we will get three. Okay, so combinations is not just some theoretical mathematical concept. It really has a physical meaning in the real world, and that should actually help us to understand this term. So now let us try to combine these three fruits. Okay, we'll again be using the same thing. We will try to combine two out of these three fruits. In other words, we will try to do this operation 3C2. Out of total of three fruits, we are going to choose two. Okay, so now let us just do that. So this is one possible way of choosing two fruits from a total of three. Now another possible way would be this, and the third possible way would be this. Okay, so these are the three possible ways, and these are the only three ways of choosing two fruits from a total of three different fruits. Okay, so there are a number of things here. These three fruits are distinct. Okay, in mathematics, in binomial theorem, that is always the case. These three things are actually distinct. Okay, and like I told you before, we write this operation as 3C2. We are combining two fruits from a total of three fruits. Okay, so we are choosing two from three, and the way we write it as 3C2. Okay, so very simple. Whenever we do the selection, whenever we do the combination, whenever we are taking things, okay, without regard to order, then we will use this formula of combinations. Okay, and when I mean by order, what I mean is we are only taking these two fruits, we are only taking two pens. It does not matter in which order I pick these two pens. Okay, it does not matter in which order I eat these fruits, and as long as the order does not matter, we are dealing with combinations, right? And combinations, if you think about it, they are very useful. Right? For example, whenever we are choosing, your teacher might choose a team of three people from your class. Now, in whichever order she selects, those three people will, in the end, those three people would come out. Okay, and that is what matters. In that case, the order does not matter. She can choose in any order. We are only interested in who actually was chosen, right? I mean, that's what matters there. So when order does not matter, then we are dealing with combinations. When order does matter, then we are dealing with permutation, which we'll study in a separate class. Now, mathematically, to find the value of this 3C2, there is a formula, right? There is a general formula. So we will write it like this. We are taking R things from a total of n things, and the formula to compute it is factorial n, and we'll explain what factorial really means. Okay, so for now, just take it. This is the factorial sign. Factorial n divided by factorial r, and then also divided by factorial of n minus r. Now, what is this factorial? Let us just also look at this, since we have looked at everything so far. So let us just look at factorial as well. What does that mean? So factorial is a mathematical operation. Okay, so do not be scared. It's similar to the square root, right? So exponent. So those mathematical operations we know. So similarly, factorial is another mathematical operation, and what it means is that there are two ways to write it. I can write it as factorial inside this n inside this L sign. So this L sign means factorial, or in some textbooks I can also put an exclamation mark after n, and this also means factorial of n. No matter which symbology you use, ultimately what this means is I have to, whenever I have this, the way to compute the value is I have to multiply n with all the numbers below n until 1. Okay, so I am doing this multiplication, n minus 1 multiplied by n minus 2 all the way till 1. Okay, so that is the operation. So similar to the square root operation. Whenever we look at square root, we understand that it's a mathematical operation. I need to do something with it, and there is a value which will come out. Similarly, factorial is also a mathematical operation. We do this and a value comes out. So for example, factorial of 3, I know now can find the value. What it means? It means 3 into 2 into 1, of course, and this 1 really does not cause any change in value. So this is actually 6. So now with this formula and our understanding of the factorial, we can find the value of 3CR. Okay, 3C2. We already know that it has to come out to be 3 because of our fruit experiment. So now this comes out to be factorial 3 divided by factorial of 2 divided by factorial of 3 minus 2. And this is nothing but 3 into 2 into 1 divided by 2 into 1, and then from the second term right here would come 3 minus 2 is just 1. So this comes out to be 2 and 2 would cancel, and of course as we expected the answer comes out to be 3. We will look at how to derive this formula in a separate class. We will also be looking at permutations, and we will also be looking at numericals in other classes. So definitely subscribe to this channel and don't forget to practice questions on DoorstepTutor.com, because this is mathematics. Okay, before we leave, there is one additional thing which I want to tell you, and that is that we have defined factorial of 0 to be equal to 1. Okay, and this is just definition. This is how this operator behaves. Okay, so that is, for example, we have defined the multiplication to be 0 into any number would be equal to 0. Similarly, in this case, the factorial case, we have defined it that if I take factorial of 0, it would be 1. And why was this done? This was to make, if you study mathematics, then there are certain operations which become simple if we adhere to this definition, that factorial of 0 when we take it to be equal to 1. Hopefully things are clear. We will look at permutations in the next class and then solve some numericals. Thank you.